Hey, hi. In this video, we are going to solve one lead code problem, which is minimum replacements to sort the array. In this video, first we will understand what the problem is all about, and then its solution, and at the end, the Python code to solve this problem. So first, let's understand this problem. In this problem, you are given an array of integers. You are seeing on your screen, these are four integers which are given to you in the form of an array, and you are also given an operation. In using this operation, you can break any integer into any number of values. Like for example, you can break 7 into 4 and 3. So in this problem, you have to sort the array by breaking those integers, and you have to sort the array in ascending order only. So here you will see, if you break 7 into 3 and 4 and 5 into 2 and 3, then you will get an sorted array, which is 2 2 3 3 4 4. The main motive of this problem is to find the minimum number of operations to sort the array. So let's see how can we solve this problem. But first you have to observe one thing. You will always be having one upper bound on the right side of the array. Like if you want to break 7 to form an array into ascending order, you don't have to exceed the upper bound which is there on the right side of the array. Like here, the upper bound is 4, so you have to break 7 in such a way such that the maximum value after breaking should not exceed the upper bound, which is 4. And in 5, you can't exceed the value which is the minimum value that you will get by breaking 7, as that will be the next upper bound for 5. Similarly for 2. Now let's understand it a bit more. Initially you have an upper bound of 4, as you have to move from the right side. Now you can break 7 only in such a way that it can't exceed the value 4, which is 3 and 4. Now your next upper bound is 3, right? As the minimum value after breaking of 7 is 3, and it will be the upper bound for the next value. Now you have to break 5 in such a way so that it won't exceed the current upper bound, which is 3. So you can break the 5 into 2 and 3 only. Now your upper bound is changed to 2. Now you can't break the next value which can exceed the current upper bound of 2. So you have the value of 2 remaining, so it won't exceed the current upper bound. So you don't have to perform any operation on 2. So in this way, you can sort the array using 2 operations by breaking 7 into 3 and 4 and 5 into 2 and 3. So how can we divide the values now for a given upper bound? One thing that might be coming to your mind is dividing the value with existing upper bound and using the remainder as the next upper bound. But it's not going to work. Why? Let's see. Let's take one more example, which is 3, 9 and 4. Now your current upper bound is 4. You have, and going with that approach, you will divide 9 in such a way, 4, 4 and 1. And your upper bound will become 1 now. Now you have to divide 3 such that its maximum value won't exceed the current upper bound, which is 1. So you need to perform 2 more operations on 3. So after this, you have to perform 4 operations to sort the array. But you can sort this array using 2 operations only. Let's see how. Your initial upper bound is 4. Now if you divide 9 into 3 values, which all of them are equal to 3, then you have to perform only 2 operations and your upper bound will become 3. Now for the next value, which is 3, you won't have to perform any operation as it is already less than or equal to the current upper bound. So at all, you have to perform only 2 operations. And also one thing to observe is that while dividing the value, you have to make sure that your next upper bound will be as maximum as possible, so that you don't have to perform more operations in the coming values. So now again the question comes, how to divide the values. Now let's understand the mathematics behind that. You are given 4 as your initial upper bound, right? Now what can you do to find out the optimal division of value 9? First, you can find out the minimum number of partitions that are needed here, which is ceiling of the value divided by the current upper bound, which is 3 in this case, as ceiling of 9 divided by 4 will lead to 3 as the next number of partitions for the value of 9. Number of operations needed for these number of partitions is partitions minus 1, which is 2. Now what will be the next upper bound? You need to understand one thing. You already know the number of partitions here, which are 3. So you have to make sure the equal distribution of the values from 9 among those partitions, as that will lead to the maximum next upper bound. So you have 3 partitions, you have a value of 9, you have to equally distribute the value from 9 among those partitions, which is 3. Now as 3, 3 and 3 are the most optimal distribution among those partitions. So one thing here you need to observe is that your new upper bound should be the value which is floor of the value divided by the number of partitions. In this way you will get the equitable distribution of values among the partitions. So this is the approach to solve this problem, to get an sorted array from the current array of values. Now let's see how to solve this problem using Python. First we will define the function which is minimum replacement in the class solution. Now here array is the array of values, right, which we have to change into an sorted array by the operation. First we are finding the size of the array using variable n. Then one more variable is used, which is the current upper bound, which will be the last value of the array as we have discussed in our solution. So this is the first upper bound, which is the last value of the array. Now one more variable which will be needed is the number of operations, which is initialized to 0 as there is no operation done till this point of time. So now we start iterating from the end of the array, which is in reverse order, except the last value n-1, as we have already taken that as an upper bound, current upper bound. Now first we have to find out the number of partitions for a current value which is at array of index. So in this way we can find out the ceiling of array of index divided by the upper bound, current upper bound. Then so this partitions store the count of the partitions for a particular value. Now we will update our upper bound, which will be the floor of the array of index divided by the number of partitions, like equitable distribution of the value of array of index among the partitions. Then we will update our variable operations by incrementing it with partitions minus 1. And at the end we have to return the number of operations that are needed to sort this array. I hope you are able to understand the solution of this problem. If you face any problem, then please comment it down. I will definitely try to help you out there. Thank you so much for watching this video. Thank you.